Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about heating, ventilation and air conditioning or HVAC. So let's dive deep into it. Now, what is this and why it is important? Well, more and more humans are staying indoors and when you put a large group of humans, does not matter young or old or man or woman, does not matter. As long as you put humans in a concentrated environment like schools, colleges and hospitals, they become very hazardous. The environment becomes very hazardous. And you have to understand there are two primary sources of that hazard. First is CO2 and another is body heat. You have to understand our body is very sensitive to CO2 poofing because here's the deal. We get poofed if CO2 goes too much. Basically at 11%, you're barely gonna be conscious. At 15%, you're dead. So you have to understand we are very sensitive to CO2. So you have to make sure that your CO2 level is always maintained optimally. Second, body heat. Because again, each human can be easily, even if they are not doing anything as in sleeping, they could be producing as much as 100 watt or maybe more. And if they are doing something, that can go as higher than you can expect. Like that's why people who are doing HVAC for gyms, they're like, why the heck bills is so high? Yeah, people are burning far more calories, aka heat output. So fundamentally, that does become an issue. You have to manage. Again, they also have to deal with CO poisoning. So it's a very hazardous scenario. So basically, till few years ago, Pentagon was classified as the world's largest official building. Like this is a building with an office. Right now, that record is held by a company in Surat, not even company, government department, diamond sector. So that is huge. Now, if you're putting that many, these things, basically CO2 and body heat becomes exponentially multiplied. So that's a serious thing. And humans, we have a very narrow range of operational parameters, so to say. So temperature has to be maintained precisely within a level for maximum comfort. Humidity, only within a narrow zone where we are comfortable. If it goes up or down, both are bad. And gases, which again, we have to be damn sure about gases because you can have carbon dioxide, carbon monoxide. These things can poof us at very low concentration, like very, very low concentration. So those are vectors, and there are many more, but it has to be controlled. And HVAC takes care of these things in a large building. In small household, you can survive without this, but the moment you start to go big things, yeah, it slowly goes from like, it would good to have to like, no, you have to have it. Like it no longer is like, no, you have to have it. Failure to do so will cost you a lot. So it's one of the large buildings, apartment complex. Unfortunately, in this India kind of lagged behind. We did not took this seriously, and as our temperature grew, basically you have giant apartment complex in India, and all of them have tiny air conditioner. Basically, it is so inefficient, so wasteful. It's just a bad idea. It's like it's bad on so many levels, from environmental point of view, energy cost point of view, every point of view is bad, and it does not even work that well. So fundamentally, we have to make sure when you have large load, you have to utilize a centralized HVAC systems. And some needs even more stricter control. Basically, I specified three things: temperature, humidity, gases. While those are good, but the moment you go into operation theater, that goes to whole another level. Basically, people learned it the hard way that if you have an operation theater and a lot of turbulence, it will cause a increased risk of what we call reinfection. So people learned it the hard way. So how do they solve it? Basically, where the patient bed is, basically where I was lying when they were drilling in my spine, is like you had there, and there is a giant thick column of air flowing down. One thick column. And again, even the lights were designed with a hollow tube, so it can easily pass through it, and like, and yes, so it does not recirculate and create turbulence, because turbulence was the bad part. So it can keep the particulate matter in air for extended period of time. They had the return line on the bottom, like corners of the rooms at the bottom level. So it like completely such. So you will not notice airflow, because again, that was another thing. You do not want high velocity, you just need high flow. So that's how operation theaters are dealing with this problem right now. And if you want to go even higher grade, then you go to semiconductor fabrication facilities. Those things are so freaking clean, they will make a hospital look like a dirty place. So fundamentally, there are scenarios where you need even more control. You need to control dust, microbes. So those things are very serious hazards in some scenarios. And these are the primary energy guzzlers in our civilization. Basically, if you remove industry, where is most of the energy going? HVAC. Most of it. Like you would be shocked. You will think, oh, data center and all that. Nah. Even with AI, nah. You come to HVAC, it's like, oh, it's huge. So that's why it is such an important topic. So first we start with airflow. Now structure must be airtight as possible. It does not need to be absolutely sealed, but it needs to be as airtight as possible. Only then you can control all possible variables, because if you do not control all possible value, not only you will have a very high running cost as in your electricity bill, the things will not even last very long. So, and again, you will be very uncomfortable also. So for that reason, you must have as close to airtight as possible. Now some leakage, no problem. Heck, it might even be desirable, but you do not want open windows. So you have to spend some time to make sure that your structure, be it building, be it school, be it hospital, is actually as close to airtight as possible. So that's the first thing, as close as possible. And then airflow must also have a return line. This is a common misconception for people who are just getting into this sort of centralized system, is that, oh, air conditioning, air coming. No. It also needs a return. So air comes in this, goes away from that. So generally you will have one area where air is coming in, another area air is going out. It has to go through whole of it, circulate properly. Otherwise, again, CO poisoning. So fundamentally, a return line must also have, which is exhaust line, so to say. And you might require some sort of energy scavenging, something like this, where you can preserve the energy you put into the air. Because let's say outdoor air in India is 55 degrees Celsius. I cooled it down to 25 degrees Celsius. After it captured heat of my computer and my body, it may be, let's say, 30 degrees Celsius. It's still 25 degrees Celsius, cooler compared to the outside. So I'm wasting a lot of energy. So this sort of system allows us to scavenge that energy. That is generally desirable, especially if you want to run the system 24/7, which again nowadays we have to. So that's there. And recirculation must be done. Otherwise, that's a bad thing, CO poisoning. And recirculation must go through filter. This is another aspect. Sometimes people kind of, cut cost and all that. No, it has to go through circulation, meaning there must be something that filters it out, cleans the things. So if people are allergic to pollen and all that, those filters will take care of it, meaning you will have completely healthy scenario. And a lot of companies experimented with these sort of things, because once doctors were actually recommending it, they were not taking it seriously. But somebody like, okay, let us try. We have two branches, identical system. Okay, in one we'll invest in the recirculation line, we'll invest a lot of heavy filters, like quality, high quality filters. Turns out it affected enough of air quality that people's sick leave actually dropped. Again, it only makes sense on a large data set. So they were testing it on a large database, but it worked. It's like people falling sick went down, because again, if you have air circulating through the office, most people's immune system is like, I got this, but some people does not have like, I got this. So if air particulate circulates and spreads around in the whole building, that's a really bad case scenario, because you may have like one person was sick on the ground floor and it affected the person in 5th floor. So once you have filtered, that problem is solved. So fresh air must be filtered. That's why filtering is very important. And outdoor air must be treated before you dump it. Basically, you do not just want like hot air directly going into your insides. It's like, ooh, that's bad. Treatment, and I do not only mean for temperature, also for humidity and also for contaminants, basically filters. So airflow is the first thing. You design an airtight system. Air comes in, air goes out, and all of those things have to be maintained thoroughly, filtered thoroughly. And this is the primary reason why Americans are falling so sick. 88% of them do not clean their filters regularly. And when they pull it out when it's completely black, it's already too late. Now we come to air conditioning. Now this is the thing where mathematics plays a role. Sizing is the key of it, meaning more often than not, people just buy a much larger unit. So if the calculated it turns out to be, let's say, 3-ton unit will be suffice, they'll buy 5-ton. And again, it's one of those things where it pays to be safe. And again, companies learned it the hard way that people do not maintain or service their equipment. So if you have large enough capacity and it degrades due to poor maintenance, it still would be within tolerance range and people will not complain. So that's why like sizing is the key. But generally people jump onto much larger oversizing than undersizing. Like you would be shocked how much planet's energy consumption is happening simply because air filters are not clean in HVAC. Like you would be shocked. And what are the loads that it has to remove? First, heat load of people. Again, if you're talking about office, heat load of people is not much. But if you're talking about college and schools, lot of people in very concentrated places, lot of heat. So you have to take care of that. Plug load. Basically, if you remove the electrical consumption of the air conditioning, how much unit of energy you are consuming. For example, if my electrical consumption is 200 units in a month, as in kilowatt hour, that means my air conditioning system must be able to leach that much heat. And that's why data centers are so hard, hard to cool. They could literally have plug load of, 50 megawatt. It's like, what? So people's load and plug load, those are there. And if you are in very high humid environment, air drying, yeah, that becomes a brutal pain, especially like in place like Calcutta. Ooh, if you have high humidity, that's like latent heat of vaporization. That's a whole another level of pain that you have to deal with. So these three things are the primary bulk load of your heat, and you must calculate your system accordingly. So again, even though a volume of a room could be the same for your house versus your school building will require much more cooling simply because there are so many children. And if it's in a gym, you will require a lot of overspecking, because again, people are burning energy there. So you could have a scenario where normal people are just like 250 watt heat load rather than 100. So that's there. And it must be able to handle seasonal swings. So basically, summer going ultra hot to winter freezing. It must be able to do that, because there is no other fail safe. It is what it is. So it must be able to handle the swings of like super hot to super cool. It's like, I got this, fam. Now, the old days, we utilized cycle controlling, meaning you just turn it on, keep it on for 15 minutes, then turn it off for 5 minutes, then turn it on for 5 minutes, then turn it on, like off and off, 5 minutes, 5 minutes. So first time it will be long, because again, let's say I turn on the AC at night and it's just like, everything is hot. So it's like, okay, I'm going to work my ass off to cool everything now. So temperature goes like, what tests the temperature here, but it goes down lower than that, because again, you do not want your AC going, it has to go down for some, then it's like, okay, then it lets waits. But again, temperature started to go above my set point. Let's say my set point was 25 degrees Celsius. It starts to go up, up, up. And after a point, AC is like, whoa, 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 whoa. Then it starts to cool down. Then it goes too low. Then it goes up. So there is a lot of oscillation in this cycle control. Now, when you're talking about house and not too much heat load, the air mass acts as a buffer. So you can notice it, but it's not that big of a deal. But again, it's uncomfortable and it does feel noisy, and it's also bad for compressor. Compressor do not like to shut off. If you keep it running, the oil will keep lubricating everything. Everything will be fine. You turn it off, oil seeps out. Then it's like, oops. So in many designs, it's imperative that it keeps working. So cycle control was okay. Like it got us from, let's say, 1800s to now. But we need variable output, meaning if you look into motor air conditioner, basically any air conditioner who has words like VLDC or inverter, generally that's what they are talking about. So the compressor will go like full power, 1500 watt, YOLO. Temperature comes down, then it pulls up. But here's the, instead of turning off, it goes into low power mode. I have seen some air conditioner that goes from 1500 to as ludicrously low as 250 watts. So your oscillation becomes so tiny, it's like imperceptible. So basically it's a leaching system where it's just like leaching. It's not like, let me undercool, and then it's like, no. It's like fine, it's very smooth system. And it also solves one of the major issues, especially if you have good electricity, where it's like turn it on and it stays on for the whole night. It's like at the morning, it starts to feel too cold. Again, AC cannot do anything. It's just like if it stays off for too long, it overheats. If it stays on for too long, you freeze. So what the hell to do? Now, modern AC is like, I got you, fam. It will drop its load. It's like, I got you. And again, that's just on the compressor side. To make the system even more efficient, we started to utilize these puppies, which we call electronic expansion valve. Basically, these two things are good throttle systems. So it's like, I got you. So you can fine tune the system and optimize the load. That's one of those things. And to make sure that, what do you do in winter? Well, you use four-way reversing valve, basically these puppies, and they just basically convert the system. Basically, your outdoor unit becomes the evaporator and indoor becomes the condenser. It requires reversing valve because, again, most compressors are not designed in such a way that you can reverse run it. It has like a low pressure and a high pressure. It cannot be switched. So we use four valve system. Now, this is not as great as we wanted it to be. The technology is kind of new only. This air conditioner, I was planning to buy another one that does not have it. Like, surprisingly hard to find them in smaller units, is that it runs on compressed refrigerant pressure. So it does leach off certain pressure. So when I was planning to buy this AC that I have here right now, it's a Blue Star unit. That puppy is like, yeah, 5-star. If like cooling only 5-star, take it and go. Cooling and heating, nah, 4-star only. Simply because these things leaches off some amount of power. Now, be mindful, that's not an issue on a larger system, and a really large units, it does not make a difference. So a small unit, it is a bit inconvenient. So I do expect somebody to invent an electrical unit like something like this for this also. That was really awesome, but that's there. So this is how we deal with ACs. You size it properly so you have good quality of service, heat, plug load, and air drying. Again, air drying is very important in certain locations. So that's why your geography matters. And it must be able to handle seasonal swingings. And cycling control, again, it used to be good, but now it's like, no. So now we have a system where it's like, properly maintaining it. and 4-way reversing valve for winter times. And yes, it does work in even American winters. It's just you have to size it properly, and the system should not be too leaky. As in, like your house, if it's leaking like hell, then this system is like, bro, what the hell? That's not my problem. Now we come to the outdoor unit. Now, outdoor unit has only two tasks. One of two tasks. One is dumping or another is extracting, meaning in winter it will extract heat, in summer it will dump heat. There is nothing more than that. So it just extract heat or dumps heat from ambient air, nothing more to do. It could be a very small unit, like something like this. This also is a huge unit from my point of view. Like in my household, the unit is half of this size. Or it could be huge cooling tower like this, which drinks water like there is no tomorrow. And if you ever wonder why cities water consumption is so high, it's not because of industry, it's because of these things. Cooling towers drinks water like there is no tomorrow. And data center, they can drink lakes dry. Has happened. That's how we know. So they're like brutal. They just drink water. Like good. It's basically running an evaporative cooler rather than an air conditioner. Air conditioner dumps heat into loop. That loop's dumped into the atmosphere. It can't dump enough of it. So it's like, yeah, might as well evaporate the air. So evaporate the water. So that you have a range of sizes available, and system must have air filtration and sterilization. Nowadays it's becoming kind of important to do both of them. Back in the old days it was like sterilization and all that was only done in hospital units, but nowadays it's kind of becoming, yeah, it's better to have it everywhere. So that's it. And it must be placed in a place where it's easily serviceable. Again, India kind of messed up with this department also. I do have to commend the people in America, at least when they build their buildings, all of the things had like proper access, and like it's not just like figure it out how to put it there and forget about it. No. You actually go there, you put it, you service it, everything is done. I have to say that does show that you have experience with this, much more experience than we do. So that is there. And then you have heat recovery ventilators like these puppy. So this puppy allows us to basically your hot outdoor air, which is 50 degrees Celsius, your heated air from all the cooling load of the house, it could be 30 degrees Celsius out of 50 degrees. That is 20 degree delta. That is enough for a passive heat exchanger, air to air heat exchanger, to dump heat, meaning your outdoor air gets cooler, which is again for fresh circulation, and the outdoor air does not waste energy on the outdoor. It's like, hey, pre-cooling. So this allows us to have, like, again, same way like a better load management in air conditioner allows it to run continuously. This can also allows you to run fresh air system continuously. It's not like, okay, I'm gonna wait for CO2 to go up, then I'm gonna flush it. No, continuous flushing, it can be done. And again, if the system is big enough, you can just have another compressor system running there to reverse the flow, and it will work quite efficiently because delta is not that huge. It will be like a pre-cooling system. So that option is there for scavenging. It's very energy efficient for heating and cooling. It works in both. Although there are certain options, rather than having metal, basically where you cannot have any exchange of material, there is one where you can exchange the moisture. Although I do not know why would you need to do that, but again, that's a normal thing in India. A lot of people have said that it saved their life when they were in basically frigid winter, so to say. You need enough moisture in the air, so it's not destructive to you. So in those sort of scenario, it kind of makes sense. So instead of making out of metal or impermeable stuff, it's made out of a paper-like structure. So water moisture can go in and out. So these are the things that we do for outdoor unit, and again, they have to be serviceable. They have to be easily. Servicing is the most important thing. Basically, you want to reduce your nation's electric draw. Make sure everybody services these puppy once a month, and you will be shocked how little energy you need. Then we come to the control aspect of it. Now, without sensors and feedback loop, this will not work. Now, again, for American people, this is kind of obvious. It's like when they say, don't twiddle with the thermostat, that's what they're talking about. And the thermostat itself has the basically thermometer itself. Even the digital ones, they have that. So without that, it cannot work, because again, the units are generally oversized. It will either cook you or freeze you. So for that reason, it has to have a control feedback. Otherwise, it's not. Assuming you can afford if it's inefficient. So it's in everyone's best interest that it only turns on when it's needed and goes off when it's not. And modern systems have bonkers amount of sensor, because again, the old system was running on cycling system. Like turn it on or off. If you send that command to modern air conditioner, it's like, bro, you are gonna destroy my compressor. So modern system is like, how much cooling you want, full cooling or less cooling. So you have a PWM signal where it's like, okay, go YOLO. So based on that, the compressor goes YOLO for first few minutes, and then it's like, okay, let's come down to 75%. Okay, it's going in nighter. It's like, how it's starting to radiate heat away. So yeah, it's temperature starting to go, okay, now drop the 50%. Okay, now try dropping it to 5%. So At 5%, a compressor might just turn off. It's like, again, you could have a handshake between the thermostat and the AC. Modern systems do require those sort of system, and without it, all vectors cannot be managed, meaning how much air you are importing from outside depends how much load of CO you have. So, carbon oxide and carbon dioxide, all of those things require a sensor, airflow sensors, and then you have pressure drop sensors. These sensors are very important because these are the first thing that tells you, yo, clean your filter, my man. And I hate so much marketing right now in India. It's like, I have ACs. I'm not even joking. That's like, we have AI. I'm like, do you have a pressure drop sensor? Again, the sensor is not expensive. Sensor is like $5 for me. If you're buying bulk, it's 5 cents. So it's like, put that from input of the filter and exit of the filter, so I can see whether it's like clogged or not. It's not expensive. It's a micro MEMS device. So it's like they don't have that, and it's like it has AI. It's like better have a filter sensor, like have like pressure and temperature sensor on both end of the compressor, as in like low pressure and high pressure, so I can detect when gas starts to leak before it leaks and too much and it becomes an issue. None of that, but we have AI. It's like, what the hell? So temperature, again, temperature also allows the AC to work properly, and CO and CO2 sensor, so how much fresh air to mix. You do not want to overdo any aspect of it. So to make sure all of these things work properly, we need to have control matrix. And a good control matrix allows you to detect issue before it becomes too bad. That's why people invest in like, pressure sensor. Like, does that matter? Yes. Like if you can detect a pressure sensor will be a range. A fresh filter would be this range. And then it slowly starts to drop. But if it goes this much, like if people show, oh, you have to clean your filter and filter is completely blacked out, yeah, you messed up, man. Like if it's that bad, it's already done. So fundamentally, you have to have a sensor that warns you before it goes bad. Like that's why I said, like majority of people will save surprisingly large amount of money. And if collectively as a humanity, we start to do this once a month, like people will like, why we were worried about power consumption? That's how big of an impact it will have on the global energy consumption. So this was my presentation on HVAC. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.